Lesson 2. Hello, Spring Boot. Convention over configuration. Objectives of the lesson. Understand what Spring Boot is and the problems it solves on top of the Spring framework. Learn the core philosophy, convention over configuration. Discover the 3 pillars of Spring Boot: starter dependencies, auto-configuration, and embedded servers. Understand the purpose of the Spring Boot application annotation. Create and run your first Spring Boot web application. Introduction. Welcome back. In our last lesson, we saw the power of the Spring framework. It untangled our code using dependency injection, but you might have noticed, even in our simple example, there was still some setup. We had to create a configuration class, manually instantiate the application context, and add the Spring dependency to our pom.xml. Imagine doing that for an application with database access, web endpoints, and security. The configuration, while better than XML, can still become complex. This is precisely the problem that the Spring Boot project, which started around 2013, set out to solve. The goal was not to replace the Spring framework, but to make using it radically simpler. It introduced a strong philosophy, convention over configuration. What does that mean? It means the framework makes intelligent, sensible assumptions for you. Instead of you having to specify every single detail, Spring Boot says, I see you've added a web library. A typical web application needs a web server, a way to handle requests, and a way to convert data to JSON. I will set all of that up for you by default. If you don't like my choices, you can easily override them. Think of it like this: the Spring framework gives you all the high-quality, individual ingredients to cook a gourmet meal. You have the flour, the spices, the fresh vegetables. You have full control, but you also have to do all the work of measuring, mixing, and combining. Spring Boot, on the other hand, is like a high-quality meal kit. It packages all the necessary ingredients, pre-measured, along with a simple set of instructions. It assumes you want to make a specific dish, say, a web service, and gives you everything you need for that dish in one box. You get the result much faster, but you can still add your own special spices if you want to. Spring Boot achieves this magic through 3 main pillars. First, starter dependencies. Instead of you picking 10 different libraries for a web application, you just include one starter, Spring Boot Starter Web. This single dependency pulls in everything you need: Spring MVC for handling web requests, a Tomcat server to run it on, and libraries for data handling. It's the meal kit box. Second, auto configuration. This is the most powerful feature. When your application starts, Spring Boot looks at the libraries on your class path, the dependencies you've added. If it sees Spring Boot Starter Web, it says, a web application, and automatically configures all the necessary beans, like a web server and the components to dispatch requests. It does this for databases, messaging queues, security, and much more. This is the smart instruction card in the meal kit that adapts to the ingredients it finds. Third, embedded servers. Traditionally, you would build your Java web application into a special file called a WAR file, and then deploy it to a separate, pre-installed web server like Tomcat. Spring Boot flips this model. The web server, Tomcat, by default, is embedded inside your application. This creates a single, standalone jar file that you can run anywhere with a simple Java jar command. Your application contains everything it needs to run. So, to bring this all together, Spring Boot uses starter dependencies to simplify build configuration. It uses auto-configuration to intelligently set up your application based on those dependencies. And it uses an embedded server to create a simple, standalone, runnable application. All of this is enabled by one single, powerful annotation you'll place on your main class, at Spring Boot application. This one annotation effectively turns on auto-configuration, tells Spring where to scan for your components, like the add component from our last lesson, and marks the class as a source of configuration. It's the master switch for the entire Spring Boot experience. In the guided practice, you'll use start.spring.io, conceptually, and your AI assistant to generate a brand new project. You will create a simple web endpoint and see how incredibly little code and configuration are needed to get a running web service. 1. What this lesson covers. This lesson introduces a minimal Spring Boot web application, focusing on how a simple HTTP endpoint is wired into the application lifecycle. You'll see how the build configuration, auto-configuration, and a lightweight controller come together to deliver a running service quickly. 2. Project layout. The project follows the conventional structure with a main application class and a web controller placed under the main source tree. This structure lets Spring Boot discover and bootstrap components automatically without extra configuration files. 3. Build and dependencies. The build is managed by Maven using a single parent platform that aligns Spring Boot versions and dependencies. This ensures consistent, compatible libraries and plugins so you can compile, run, and package the application with minimal setup. 4. Application startup. At startup, Spring Boot creates an application context, scans the package of the main class for components, and auto-configures a web server. The embedded server starts automatically, allowing the application to listen for incoming HTTP requests without external setup. 5. The main application class. The main application class marks the entry point and signals to Spring Boot where to begin scanning for components. Its role is to bootstrap the application context and trigger the auto-configuration that brings up the web layer. 6. The web controller. A simple controller demonstrates how to map an HTTP path to a method that returns a response. This shows the core pattern you'll reuse: define a route, handle the request, and return a result that the framework serializes or renders. 7. Running the app. You can launch the application directly from your IDE or via the Build Tools integration with Spring Boot. When it starts, an embedded web server will be available locally, and the mapped path from the controller will serve a response. 8. Verifying the endpoint. Open a browser or use any HTTP client to make a request to the configured path. You should receive the response defined by the controller, confirming that routing, binding, and the application lifecycle are working together properly. 9. Configuration basics. Out of the box, Spring Boot uses sensible defaults. You can override behavior using conventional configuration files if needed, but this lesson emphasizes how far you can go with zero configuration by leaning on auto-configuration and component scanning. 10. Packaging for distribution. The build produces an executable artifact that already includes the embedded server and all dependencies. This makes distribution straightforward. The application runs the same way across environments without installing a separate application server. 11. Common pitfalls. If the application does not start, check that the package structure allows component scanning to find your controller and that dependency versions are consistent. If the endpoint is not reachable, verify the path mapping and confirm the application started without errors. 12. How this scales. The same patterns extend naturally to more endpoints, request parameters, structured responses, and layered architecture. As the app grows, you can introduce services, configuration profiles, and testing, all supported by the same conventions. 13. Key takeaways. Spring Boot reduces setup to a few essential parts: a build file that manages aligned dependencies, an entry class that bootstraps the app, and a controller that exposes an HTTP route. With those pieces, you get a working web service quickly and predictably.